At nearly 400 miles per hour, Germany's fighters couldn't catch it. No guns, no armor, built from wood and glue. When Luftwaffe engineers dismantled a captured de Havilland Mosquito, they expected scrap. Instead, they uncovered a technological insult, one that proved imagination could outrun steel radar and an empire at war. And suddenly, one question haunted the room. How did glue outrun steel? The hangar outside Hamburg was dim wet and echoing with rain. Floodlights cut through the darkness, revealing something that didn't belong in a war built on steel. The wreckage on the floor didn't smell like burned oil or cordite. It smelled like varnish, like fresh-cut wood. German engineers stood silently around the disassembled airframe, their white coats already stained with graphite and grease, staring at pale wooden panels that looked more at home in a cabinet shop than on a battlefield. They had been told this was a captured de Havilland Mosquito, the fastest bomber the British possessed. Faster than Messerschmitts, faster than Focke-Wulfs at full throttle. That claim alone had sounded like propaganda. Now under the lights, the idea bordered on absurd. The fuselage wasn't armored. It wasn't riveted. It wasn't even metal. One engineer laughed under his breath. "A wooden bomber," he muttered. "The English must have run out of aluminum." Dr. Karl-Heinz Henkel, a senior materials analyst for the Luftwaffe, stepped closer. He adjusted his glasses and rapped his knuckles against a wing panel. The sound wasn't sharp or hollow. It was dull, heavy, like knocking on a coffin. His smile faded. This wasn't scrap wood. This was something deliberate, engineered. When a chisel snapped, trying to separate two layers, the laughter in the hangar died completely. As the rain hissed on the roof, a sharp, sweet chemical scent filled the air, phenolic resin, unfamiliar and unsettling. The engineers began to understand they weren't looking at a curiosity. They were standing over a weapon that had humiliated German air defenses for nearly 2 years. In that moment, the question changed. It was no longer what this aircraft was made of. It was how something so light had made German steel feel obsolete. The examination began casually, almost arrogantly. The engineers moved in with notebooks and calipers, expecting quick answers and easy flaws. They measured thicknesses, weighed fragments, scribbled numbers that should have confirmed their assumptions. Wood was weak. Wood burned. Wood failed. That was doctrine. That was certainty. Yet every figure that landed on the clipboard told a different story. The panels were impossibly light but stiff, smooth but resilient, built not like an aircraft, built like a single organism. A technician pried at a seam expecting rivets hidden beneath filler. There were none. No bolts, no weld lines. The joints flowed seamlessly from one surface to the next, reflecting the floodlights like polished marble. When they cut deeper layer by layer, the structure revealed itself, thin birch skins surrounding a core of balsa, all fused together into something that defied classification. Not wood, not metal. A composite, decades ahead of its time. Dr. Karl-Heinz Henkel watched in silence as test after test failed to behave correctly. Tensile loads exceeded aluminum at half the weight. Vibration that would fatigue metal skins simply disappeared into the structure. When they applied heat, expecting softening or delamination, the material grew harder, stronger. The adhesive did not melt. It cured. Thermoset. Final. "This isn't glue," Henkel said quietly. This is structure. By midnight, the hangar floor was buried in wood shavings, broken tools, and cold coffee cups. No one was laughing anymore. The Mosquito wasn't fast because it cheated physics, it obeyed them better. Its smooth skin reduced drag. Its flexibility absorbed stress. Its lightness turned speed into protection. As Henkel stared at the curved wing root under the lights, a realization settled in like a chill. Germany hadn't been outgunned. It had been outthought. 2 years earlier, long before German engineers stood baffled in a rain-soaked hangar, a single man had walked into the British Air Ministry with an idea that bordered on professional suicide. His name was Geoffrey de Havilland. He was calm, precise, and stubborn in a way that made bureaucrats uncomfortable. When he laid his drawings on the table, the room leaned in expecting innovation. What they saw instead felt like an insult. The bomber on the paper had no defensive guns, no armored plating, no gun turrets bristling with bravado. And most unforgivable of all, it was made almost entirely of wood. The officials listened politely, then rejected it without hesitation. Modern war, they insisted, would be won by aluminum engines and firepower. Wood belonged to museums and biplanes, not the future of aerial combat. De Havilland did not argue. He had already done the math. Britain was running out of aluminum. Every pound went to fighters and heavy bombers that grew larger, slower, and more vulnerable with each new requirement. De Havilland saw something others missed. Speed did not need armor. Speed was armor. Strip away guns, turrets, and excess weight, and the aircraft would not need to fight. It would simply refuse to be caught. More importantly, Britain still had something else. Thousands of craftsmen scattered across the countryside, furniture makers, piano builders, cabinet workers whose hands understood curves, tension, and precision, men who could shape wood to tolerances tighter than many factories could manage metal. De Havilland believed that if war was becoming a contest of resources, then imagination would have to replace abundance. What he was proposing was not just an aircraft. It was a quiet rebellion against everything modern air warfare believed about strength. When war arrived in 1939, de Havilland's idea should have died quietly. The Air Ministry demanded armored bombers with guns and crews measured in dozens. Yet reality intervened. Aluminum shortages deepened. Factories were stretched thin. And quietly, almost reluctantly, the ministry approved a single prototype. Not because they believed in it, but because Britain could no longer afford to ignore unconventional answers. What followed looked less like aircraft production and more like a craft guild mobilization. Across Britain, furniture workshops were repurposed overnight. Piano makers shaped wing spars. Violin builders carved compound curves for the nose. Cabinet makers laminated fuselage shells over concrete molds. The aircraft that would become the de Havilland Mosquito was assembled not with rivet guns, but with clamps, presses, and patient hands trained in millimeters and grain direction. The structure was radical in its simplicity. 2 molded fuselage halves built from birch plywood sandwiching a balsa core. Each layer bonded with phenol formaldehyde resin and cured under heat and pressure until wood and adhesive became inseparable. No internal bracing, no stress concentrations. The result was a smooth, airtight shell that carried loads evenly across its skin. Lighter than metal, stronger than expected, and aerodynamically cleaner than anything the RAF had ever flown. To engineers raised on steel, it looked fragile. To craftsmen, it looked obvious. Wood flexed instead of cracking. It absorbed vibration. It tolerated battle damage without catastrophic failure. In chasing speed, de Havilland had accidentally created something else entirely. A composite airframe decades ahead of its time. The Mosquito was not pretending to be a metal airplane. It was something new. A machine born where chemistry, craftsmanship, and necessity collided quietly, preparing to rewrite the rules of air combat. On the morning of November 25, 1940, the prototype rolled onto the runway at Hatfield beneath a low-gray English sky. It was painted bright training yellow, an almost mocking color for an aircraft no one truly believed in. Ground crews watched quietly as the engines were primed. There was no dramatic send-off, no expectation of history. Just a strange, unarmed airplane made of wood preparing to justify its own existence. In the cockpit sat Jeffrey de Havilland, Jr., the designer's son. He knew exactly what was at stake. If the aircraft failed, the idea would die with it. The twin Merlin engines came alive, their roar vibrating through the lightweight airframe. Observers braced for a long, hesitant takeoff. Instead, the aircraft surged forward and lifted cleanly, almost effortlessly, as if gravity had briefly loosened its grip. As the aircraft climbed, stopwatches came out. The numbers made no sense. Altitude came too quickly. Control response was sharp, immediate. Then came the speed run. At full throttle, the needle pushed past expectations and kept going. Near 400 miles per hour. Faster than frontline fighters. Faster than doctrine allowed a bomber to be. The men on the ground said nothing. Silence replaced skepticism. What had just flown was not a curiosity. It was proof. Proof that armor was optional. Proof that speed could replace firepower. Proof that an airplane built by craftsmen and chemists could outrun machines forged from the finest metal in Britain. By the time the prototype touched down, the argument was already over. The wooden aircraft had won. All that remained was to see whether it could survive a war that obeyed no rules at all. When the aircraft reached operational squadrons in 1941, the reaction was anything but celebration. Pilots who had spent years flying Blenheims and Wellingtons stared at the Mosquito with suspicion. It looked wrong. Too slim, too clean, too exposed. There were no gun turrets, no armor plates, no reassuring mass of metal between them and enemy fire. Just a pilot and a navigator seated shoulder to shoulder in a cockpit barely wider than a dining table, relying entirely on speed and faith. The training manuals were brutally honest. If intercepted, do not engage, do not turn, do not climb into a fight. Push the throttles forward and run. Survival depended on discipline and nerve. The aircraft was unforgiving to hesitation. At full power, the Merlin engines transformed the Mosquito into something closer to a racing machine than a bomber. Crews learned quickly that restraint was dangerous and commitment was everything. Fear followed them into the air. The first operational flights were quiet, tense affairs. Without defensive guns, crews felt naked. Every flak burst felt personal. Every distant speck in the sky threatened disaster. Yet again and again, the same pattern repeated. Fighters tried to close and failed. Flak bursts bloomed behind them, never quite catching up. The Mosquito did not evade by maneuver. It simply refused pursuit. As confidence grew, a strange relationship formed between crews and machine. Pilots described the aircraft as alive, responsive, almost protective. The wooden structure absorbed vibration instead of transmitting it. Control inputs felt smooth even at extreme speeds. Damage that would have crippled metal aircraft often resulted in nothing more than scars. The Mosquito bent, flexed, and kept flying. By the time the first combat reports reached headquarters, skepticism gave way to obsession. The numbers were undeniable. Missions completed faster. Losses dramatically lower. Crews returning unscathed from airspace, others barely survived. The Mosquito was proving something deeply uncomfortable to traditional air doctrine. Courage was not enough. Armor was not enough. In modern air war, survival belonged to whoever understood speed first and trusted it completely. The Mosquito's true test came not in theory or trials, but in hostile skies. On September 20th, 1941, aircraft from No. 105 Squadron lifted off for a mission that many believed bordered on reckless. Daylight, long-range, precision strike. The target was the Gestapo headquarters in Oslo. No escort fighters, no defensive guns, just speed, altitude control, and timing measured to the second. They flew low over the sea, skimming waves at barely 50 feet. The wooden airframes sliced through mist and spray, invisible to early warning radar, until it was too late. By the time German operators realized what was coming, the Mosquitoes were already overhead. Bombs fell cleanly and accurately. Then the aircraft were gone, accelerating away before fighters could scramble. Every crew returned. Not a single loss. Word spread quickly through the Royal Air Force. This was not luck. It was a pattern. The Mosquito was changing the geometry of air combat. Traditional bombers moved like formations, predictable, slow, interceptable. The Mosquito moved like an individual thought, fast, precise, and already finished before the enemy could react. The most humiliating blow came in January 1943. Two Mosquitoes penetrated deep into Berlin in broad daylight. Air raid sirens screamed not because of mass bombers, but because radar screens showed something impossible. Targets accelerating beyond interception limits. As bombs detonated, in the capital, German leadership realized they were powerless to stop it. For the first time in the war, air defense doctrine collapsed under its own assumptions. Interceptors could not climb fast enough. Radar could not track cleanly enough. Command decisions arrived too late. The Mosquito had proven that air superiority did not belong to whoever built the biggest formations, but to whoever arrived first and left untouched. After Berlin, the Mosquito stopped being judged as an aircraft and started being treated as a phenomenon. Crews whispered about it in mess halls. For the first time, an unarmed bomber had become the most survivable aircraft in the Royal Air Force. Loss rates told a story no propaganda department could spin. Heavy bombers were being shot down at 5 to 7% per mission. The Mosquito was losing fewer than one aircraft per 200 sorties. Statistically, it was safer to fly into enemy airspace than to cross a city street at night. The effect on the enemy was immediate and corrosive. Inside the Luftwaffe, frustration turned into obsession. Fighter units were given standing orders not to pursue Mosquitoes unless conditions were perfect. Pilots learned the hard way that chasing one usually ended in empty fuel tanks and humiliation. The aircraft could not be caught in level flight, and in dives, it accelerated beyond structural safety limits for German fighters. Speed was not just protection. It was dominance. Psychologically, the Mosquito cut deeper than its bomb load ever could. It appeared alone or in pairs, without warning, without pattern. Radar blips emerged and vanished before operators could issue commands. Entire interceptor squadrons were scrambled for nothing, burning precious fuel and exhausting pilots who never saw their target. The Mosquito forced the enemy to react on its terms every single time. German civilians felt it too. Sirens wailed for aircraft they could not see and could not stop. Resistance movements across occupied Europe celebrated its arrival as proof that the Reich was not untouchable. To some, it became a rumor. To others, a ghost. To German pilots, it was simply unfair. An aircraft that refused to play by the rules they had trained their entire careers to master. By late 1943, the Mosquito had achieved something rare in warfare. It altered behavior. It reshaped planning. It made entire defensive systems inefficient by existing just outside their limits. What began as a gamble born from shortage had evolved into a weapon that attacked not only targets, but confidence itself. The wooden bomber was no longer just flying missions. It was eroding certainty, one unanswered alarm at a time. In the spring of 1943, the Luftwaffe finally received what it had been waiting for. A Mosquito on a reconnaissance run over northern Germany was torn open by flak and forced down into marshland near the coast. It did not explode. It did not burn. When German troops reached it, they expected twisted metal and ash. Instead, they found something that looked disturbingly intact. Smooth wooden panels, pale curved surfaces, the smell of resin still clinging to the wreckage. It looked less like a crashed bomber and more like a broken boat. Orders came down immediately. Everything was to be recovered, even splinters. The aircraft was transported under guard to a secure analysis hangar where floodlights revealed it in full. Engineers circled it slowly, almost reverently. This was no longer a target. It was a riddle. The aircraft that had outrun fighters, mocked radar, and embarrassed the Reich was finally still. For the first time, Germany could touch the thing that had humiliated it. Dr. Karl-Heinz Henkel led the investigation. He had spent his career studying metal fatigue cracks and catastrophic failure. What he saw unsettled him. The Mosquito's skin was thin yet flawless. Birch veneer bonded to a balsa core, then sealed again in birch. No internal framework, no stress points. When they cut into it, the layers did not separate cleanly. They resisted. When they applied force, the wood failed before the bond did. The adhesive was not holding the structure together. It was the structure. Chemical analysis deepened the shock. The glue was a phenol-based synthetic resin cured under heat and pressure into a thermoset polymer. It did not soften when heated. It hardened. It resisted moisture. It absorbed vibration. In effect, the British had hidden armor inside wood. Germany's own wooden aircraft used casein glues that degraded in humidity and heat. This was different. This was chemistry weaponized. As the reports accumulated, admiration crept in alongside dread. The Mosquito was not a miracle born of luck. It was the product of ruthless efficiency and disciplined imagination. Every choice reflected scarcity, turned into advantage. Henkel understood the implication immediately. Even if Germany copied the shape, the engines, the dimensions, it could not copy the context that made it work. The Mosquito was not just an aircraft. It was the physical expression of a mindset the Reich did not possess and could no longer afford to learn. The order came from the top. If Britain could build a wooden aircraft that humiliated German air defenses, then Germany would build one better, faster, stronger, deadlier. The project was given a deliberately mocking name meant to sting the British mosquito and restore wounded pride. On paper, it looked achievable. German engineering had mastered metals tolerances and mass production. How hard could wood be? Almost immediately, the numbers began to betray them. The British design relied on lightweight Ecuadorian balsa, a material Germany could no longer access under Allied blockade. Engineers substituted pine and beech. Stronger, yes, but far heavier. Wing sections that weighed less than 300 kilograms on the Mosquito ballooned to over 400 in the German mock-ups. Speed calculations collapsed before the aircraft ever flew. The glue became the fatal weakness. Without access to sufficient phenolic resins, German teams reverted to modified casein adhesives. They worked in laboratories and failed in reality. Under heat, moisture, and vibration, the bond softened. Engineers knew it. Test data showed it. Reports were quietly rewritten before reaching Berlin. The Reich did not need problems. It needed victories. When the first prototype finally flew, the illusion shattered within minutes. Controls felt sluggish. Vibrations appeared at speeds the Mosquito treated as routine. During a high-speed run, the wings began to resonate audibly. Thin cracks crept along the leading edges. The pilot throttled back and landed hard, the airframe already compromised. Later tests ended worse. One aircraft broke apart in a dive when the wing delaminated midair. By 1944, the project was dead. Not officially announced, simply buried. Engineers wrote their conclusions in language thick with restraint and despair. The design could not match British performance due to fundamental material limitations. In private, the truth was harsher. They were fighting physics with paperwork. German engineering had tried to copy the shape of genius without understanding the conditions that created it. And in doing so, it exposed the limits of pride when imagination is in short supply. By 1944, the Mosquito had done something no weapon was designed to do. It changed behavior. Every appearance forced the Luftwaffe to react on its terms. Radar stations scrambled. Interceptor squadrons launched. Fuel burned. Pilots climbed hard and found nothing. Again and again, the same pattern repeated. A fast-moving blip, a delayed response, an empty sky. The Mosquito was not winning through destruction alone. It was winning by exhausting a system already stretched beyond repair. Inside German leadership, the aircraft became a personal humiliation. Hermann Göring raged openly about it. British Mosquito raids were deliberately timed to coincide with his speeches and meetings, their explosions puncturing his claims of control. Fighters that once dominated Europe could not catch an unarmed bomber made of wood. For an air force built on pride, the implication was devastating. Superiority meant nothing if it could not be enforced. Among pilots and civilians alike, the Mosquito became something more than a machine. Radar operators reported targets that outran calibration limits. Fighter pilots returned claiming they had chased shadows that simply pulled away. Civilians learned to fear its sound not because it promised mass destruction, but because it promised precision. A single aircraft could erase a rail junction or command office and disappear without warning. The Mosquito did not announce collapse with firestorms. It whispered inevitability. And that quiet certainty hollowed German air power from the inside out. When the war collapsed in 1945, the Mosquito's final victory was quiet. There were no parades for it in Germany, only silence and paperwork. In ruined offices and abandoned laboratories, reports written by defeated engineers survived the bombs. Among them were Dr. Karl-Heinz Henkel's notes. They no longer spoke of speed or interception. They spoke of mindset. The Mosquito, he concluded, was not superior because of a secret formula alone, but because it had been born in an environment that allowed craftsmen, chemists, and engineers to work without fear of failure. After the war, Allied inspection teams toured British factories. German engineers were shown how the fuselage halves were molded, bonded, and finished by hand. The smell of resin returned, sharp, sweet, unmistakable. One British engineer explained that there had been no grand theory behind it, just a willingness to experiment and adapt. Thousands of ordinary workers had built something extraordinary because they were trusted to think as well as follow instructions.